Dear students, today our topic is about the normal probability curve. Let us first see what this word normal means, what this word probability means. As far as our education is concerned, teachers are supposed to take the decisions about the child's future. And how can teacher do that? The teacher takes different tests, different types of the measurements are carried out on the students' performance or the students' behavior, and the results or the outcomes of the different tests and the different tests are statistically interpreted by the teacher. As far as this our measures of central tendency is concerned, which we have already done in the previous lecture, the measures of central tendency provide us with the average value, which is considered as the point of assessing the performance of a child. The teacher says if someone secures more than that average value, and he says that student will excel in the field, and if someone secures less than that average value, the teacher says that that student is having the poor standard. So that average value is important. It indicates that comparison starts keeping in mind the normal situation of a child, that is the average value of a child that is given us by the normal measures of central tendency. And in our daily life we also keep ourselves try to keep ourselves above average or above normal people, in case of wealth, in case of honor, in case of intelligence, or in case of lifestyle. We say that we should be above average people, or we should be above normal people, so that the society can recognize us. This is about the normal. And what is the probability here? The probability is in simple words, it's the mere occurrence of an event, chance of occurrence of an event. Suppose I have a coin in my hand and I toss that coin, and during the fall of that coin, it comes in my mind that there are two probabilities, there are two chances that I may get head and I may get, or I may get tail. If I toss the coin once, then the probability or chance of getting head and chance of getting tail is 50-50%. And now suppose if I tossed a coin 20 or 30 times, now what is the probability there of getting head, and how many times I will get the tail? That is given in statistics by the binomial distribution. And then and when the number increases, or when the events increase, then the distribution takes the shape of the normal distribution, or we say the normal probability distribution. This normal probability distribution is very frequently used, this probability distribution. It's useful because that many variables in our real life are close to the normal distribution. A normal random variable is completely defined by the two parameters, and you already know what are those two parameters. That is the central value and the how much scattered is that. That means they are defined by the this mean and the this a standard deviation, that is the scatteredness of the distribution. And then we get this normal probability distribution or normal probability curve. This is also known as Gaussian distribution because it was given by a scientist named Gaussian. And this distribution, the normal probability curve is, we draw the horizontal line, and then we draw this curve like this, which is the normal probability curve. This curve is as you can see, the shape of this curve resembles with the shape of the bell. Okay, so this is also known as the bell shaped curve. Mm. Then we there is another thing, that this curve is having the middle value, that divides the curve into two equal parts. How is it equal? We say that this part is the mirror image of this part, or this part is equal to this part. If we fold the curve along this line, the two parts will coincide with each other. Okay, so it is bilaterally symmetrical in nature. The normal probability curve is bilaterally symmetrical in nature. The size, the shape, the slope are identical on the one and on the both of the sides of the this middle value. And then we say that the normal probability curve is having a single point where all the three measures of central tendency lie, that is mean, median and mode. We say that curve is normal curve which is having the mean equal to median equal to mode. The same value is for all the three measures of central tendency. And this mean median mode is that point which divides the curve into two equal parts. Okay, then this curve, first when it starts, it reaches to the maximum, it reaches to the peak, that is the maximum value of the curve, and then slows down. Okay, and then we say that in this curve there is one more thing, that it is unimodal, it's having only the single mode. And then in this curve you can see that it is not touching this horizontal line on both sides, neither on this side nor on this side. So we say this curve approaches to touch the waistline, but it never touches the this horizontal axis, so it is asymptotic curve. It is because it never touches the horizontal line. And this curve starts from the negative side, that is from minus, and ends up at the plus. And because it never touches the baseline, so we say it starts from minus infinity and ends up at plus infinity. And then the maximum height of this curve is we say that a maximum height, or we say that ordinate of this curve is always equal to 0.398. And if any curve is having the value of ordinate more than this value, that will not be the normal curve. And if any curve is having the ordinate value less than this value, that will also not be the normal curve. That what those curves are called, that we will deal in the next lectures. And in the next point, you always keep in mind that this curve never touches the baseline. So the area under this curve, the area from this side to this side under this curve is never exactly equal to 100%. It's approaching to 100%, but it is never equal to 100%. The percentage of the area from this side to this side may be roughly equal to 99.74%, but never 100%. And then the next is that there is the shape, abrupt change in the shape from this side and from this side also you can see. And the point where the shape abruptly changes the curve is known as the point of influx. This is that point where the curve changes its it changes its shape. It is on the both sides, from this side and from this side also. The and it is also the point of influx is that point where the first standard deviation lie. Keep it in mind that we measure this curve in terms of mean and the standard deviations. Okay, then we have that how much area. We know that it's not equal to 100%, but it's approaching to 100%. But how much area lies from particular point to particular point? Let us check that this is the point of influx, and how much area lies from this point of influx to this point of influx. Keeping in mind that from mean to the right hand side there will be the positive observations and positive values, and from mean to left hand side there will be negative observations or negative values. This is the first standard deviation, from mean to one standard deviation and from mean to one standard deviation. Here it is negative and here it is positive. Okay. How much area is covered under the curve from one standard deviation to +1 to -1 standard deviation? It is, keeping in mind, it is 68.26%. Okay. And then next is how much area is covered between -2 standard deviation and +2 standard deviation from this side to this side. It is equal to 95.44%. We can say that if we have observations or if we have a cases, that we say that the number of cases that lie in between the -2 to +2 standard deviation is 95.44, okay, or 95.44% of observations. Then it is +3 to -3 to +3. Okay. How much observations lie between the +2 to -3 standard deviations? It is 99.74%. Between cases lie between the -3 to +3 standard deviation. Okay, because it never approaches that here it goes to infinity and here it also goes to infinity. It is never having exactly equal percentage equal to 100. Now this is about the this -2 to +2, and this between the roughly we can say the whole numbers. Now it comes in mind what will be the distance between these two, or what will be the percentage of cases between these two. Okay, as far as this mean value is concerned, it divides the curve into two equal parts, so this area is equal to this area. Okay, and then if I have the point of influx, the mean to point of influx from this side and mean to point of influx from this side will be equal area. And if this is equal area, then the total percentage between -1 to +1 is 68.26%. What will be the percentage between mean to +1 or mean to -1? Because it's equal distance, I divide this by 2 and I get that from mean to +or -1, the percentage of cases will be 34.13%. And then what will be the percentage of the cases from -1 to -2 or +1 to +2? Here we go that the percentage of the cases between -2 or +-2 or +-1 will be equal to 13.59. That is -1 to -2 or +1 to +2, this distance or this distance. Okay, then what is about this distance and this distance? From -2 to -3 there lie 2.14% cases, and that is similar to +2 to +3 standard deviations. And this is the percentage that you have to keep in mind for further studies. How much percentage lie between what from which point to which point. Okay, then we have that the normal curve is usually written in the standard deviation standard scores. That a standard, what is that standard score, that will we will talk about the further, but here you will only keep in mind that raw scores are converted into the standard scores. The if we are having the mean of any observation or set of observation 0 and the standard deviation 1, then we say the area under the curve is equal to the unity, and that is given by this formula. The area under the curve is given by this formula. Why? What is this? Y is the ordinate. You already know it's the maximum height of the curve, and this pi, it is the constant and it is equal to 3.1416, and this e, it's the logarithmic base, and it's also constant, it's equal to 2.718, and the z, it's the z score or the standard score that we will calculate in upcoming lectures. And this is the formula that how we calculate the ordinate of a curve. And if the ordinate of a curve is equal to 0.3989, then that is the normal curve. And if this ordinate is equal to greater than this value and or less than this value, then that is having divergence from the normal curve, that is not the normal curve. What type of divergence, that we will take in the next lecture. There are some properties of a curve which I have divided into the like cases. Case number first, suppose I have two distributions, we are having the same standard deviations but having the different means. What will happen to the curve? What will happen to the normal probability curve? The normal probability curve will lie on two different bases, okay, because they are having the middle value different. And you see here that the shape of the two curves is similar and the height of the two curves is similar, because the standard deviation is similar. Next case is when the standard deviation of the two distributions is different but the mean will be same. What will happen to the curve? As the middle value is same, so they will lie on the same base. This is the middle line. You can see that a blue curve has the more height than that of the red curve. So this we here say that this standard deviation affects the height of a curve, okay. um, what type of effect it will have, that we will take on later on, but keep in mind that standard deviation affects the height of a curve and the mean value is the same, so they are on the same base. And the third is, if we are having the if two set of observations are different, having different standard deviations and different mean, what will happen? They will have different base and different heights also. And this is the curve which is having, these two observations are having different mean and different standard deviations also. Here from this you can conclude that the standard deviation affects the height of the curve but not the mean, okay. This is all about this normal probability curve, and in next upcoming lecture we will discuss about the divergence of the from this normal curve. Till then, stay safe, stay healthy and stay motivated. Stay tuned to the channel. Thank you.